All right, so we're going to look at logarithms. Logarithms are not as strange as they might first appear. So a logarithm is just another way of expressing some exponential statement. You know, if we say 3 to the second power is equal to 9, well, there's a way of expressing that same concept as a logarithm. On an exponential statement, you raise some number to an exponent, and then you get back an answer. Well, with a logarithm, you're given the base. All right, this b is your base, just like that's your base here. Okay, you're going to take log some base of whatever the answer was, like to this question over here, and then it's going to give back the exponent that you had to raise that base to. All right, I will look through some examples. Hopefully, you'll catch on to the rhythm. It's not crazy, but as long as you're good with like raising numbers to certain powers, uh, this should be pretty straightforward. Right? Log base 5 of 25. That's how you would read that. So this is asking the question, 5, that's my base, 5 to some power is equal to 25. That's what that's asking. Right? So this is going to be equal to 2 because 5 to the second is equal to 25. Right? Be 2. If we wanted to know log base 3 of 81, right? 3 to some power is equal to 81. This one, let's see here, 3 to the third is equal to 27. And then if you do another 3, 27 times 3, you'll get 81. So you need 4 3s to make that happen. 3 to the fourth is equal to 81. Okay. How about log base 2 of 8? 2 to what power will give you 8? That's a 3. So the preferred method is to take whatever the logarithm is and rewrite it as an exponential equation. That's generally the easiest way to think of them. Right? If you want to use this formula, it's kind of helpful as far as rewriting, but a lot of people get mixed up on how to rewrite it. But in the early days, it's pretty helpful. All right, log base 6 of 1, 6 to some power will give you a 1. 0 is the only thing that'll make that happen. All right, remember anything to the 0 power will give you 1. Okay. 7 to what power will give you 7? 1. That's your answer. All right, 7 to what power will give you 7? It's the only one that works. So these are kind of special. The idea is if your base and your input are ever the same, 1 is always the answer. And for this one, it's, I guess, no matter what your base is, if 1 is your input, 0 is always your answer. Okay, those are two of them that are pretty common. These last two I wanted to look at because they are a little strange. This one's going to be undefined because it's asking the question, 1 to what power will equal 5? Yeah, this is impossible because no matter how many times you multiply 1 by itself, you'll never get 5. Okay? This is undefined. That's basically because 1's your base. All right, and here, 0 is your input. This is also going to be undefined, but for a different reason, I guess. So this one would be 2 to what power will equal 0. So we know that if the exponent here is a positive, we just get bigger and bigger numbers. If the exponent's a fraction, that's kind of like taking the square root of this number. And if you ever take the square root, it doesn't matter how many roots you take, you'll never get 0 back as an answer. Okay? There's nothing that you can raise 2 to the power of to get 0 back. You could get closer and closer. Like if you do 2 to the negative 5, you're going to get a really small answer, 2 to the negative 10. you're going to get a very small answer. It's in scientific notation. Your calculator, if you do like negative 100, oh, maybe it's 2 to the negative, maybe 1,000. Yeah. Eventually, your calculator is just going to spit back 0. This actually isn't equal to 0. It's super close, though. All right, this is a very, very small number. 2 to the negative 1,000. That would be 1 over 2 to the 1,000. This is a super big number, and when you're doing 1 divided by that super big number, you're going to get close to 0. All right, trying to draw the little approximately equal. It's almost equal to 0. But yeah, these two are kind of special cases that they're undefined. All right, moving on. All right, these first two, you'll notice that they don't tell us the base. Whenever it's just a log, okay, this is known as the common log, okay? And when it's written like that, when they don't tell you the base, it's an implied 10, okay? This is the log button that's on your calculator here. So if you do log of 1,000, you get 3. All right, and that's because 10 to the third power gives you 1,000. If you do log of 0.01, you get negative 2. Okay, that's because 10 to the negative 2, all right, that's like 1 over 100, and that's equal to 0.01. All right, on these two, so we're going to do 9 as our base to some exponent is equal to 3. So the relationship here is like it's a square root relationship, but what does the exponent have to be in order for it to behave like a square root? This is where your fractional exponents come in. X would have to equal 1/2. All right, 1/2 is the same as square rooting. All right, raising something to the 1/2 power, I should say. All right, for this one, 8 to some power will give us 2. The answer here is going to be 1/3 because the cubed root, right? That's because the cubed root of 8 is equal to 2. And raising something to the 1/3 power is like taking the cubed root of it. All right, these last two, notice how our input, it's between 0 and 1. All right, this implies that we're going to have negative exponents as our answer. All right, we're doing 2 to some power is equal to 1/4. Well, we know that 2 to the second power is equal to 4, but because we want 1 over 4, the answer is going to be negative 2. All right, 2 to the negative 2 will give us 1/4. All right, what about 3? 3 to what power can give us 1 over 27? Well, 3 to the third power will give us regular 27. So 3 to the negative third power will give us 1 over 27. 3 to the negative third power gives us this. If I make that into a fraction, you get 1 over 27. Okay. That's it for the basic ones. These are the most common ones. I'm going to look at 2 of them here in a second that are a little more challenging.